So here it says it wants us to calculate the voltage across each capacitor and calculate the charge across each capacitor. The equation that should instantly pop in mind is that how? That's the real question. How does it happen every time? Is that Q is equal to CV. And keeping that in mind, once we solve for voltage, immediately we're going to know exactly what Q is because C is given, and that's everything you need, and then we can solve for Q. So we just got to focus on voltage. Once we have voltage, we just plug it in that equation, and the second part of the question will be done. So how do we calculate the voltage across each capacitor? Well, for this one, it's essentially, it's literally voltage division again, in many ways. Here, the charge here has to be equal for both of these. They have to be equal to the exact same. So CV has to equal CV when in series. That's what's weird about capacitors. They're kind of the backwards logic of it. So resistors, when they're parallel, their voltage has to be equal. For capacitors, when they're in series, their charge has to be equal. So we can simply say CV is equal to CV. And we also know that V1 and V2, V1 plus V2 is equal to 10. Because overall, these capacitors together have to stop this 10-volt battery. And to do that, their combined voltage has to be equal to 10. Not one of them equal to 10, both of them combined. So there you go, you have two equations, two unknowns. This is pretty easy, so I think I'll just do this with you right now. We know that 2 farads, we'll have 2 farads, but the V1 is equal to 4 farads of V2, or V1 is equal to 2 V2, and then we do 2 V2 is equal to 2 V2 plus V2 is equal to 10 volts. 3 V2 is equal to 10 volts, or in other words, V2 is equal to 3.33 volts. And you can plug this directly into here and see that V1 is equal to 6.66 volts, which is good. V1 should be the larger value because, again, that charge has to be the same. So because this is a smaller capacitor, its voltage has to be larger to keep up with the larger capacitor. And it really is that simple. So this one's